Today we'll be talking about combinations or you could call it elimination with systems of equations. So before you guys learned how to graph it, find the point of intersection, then you learn substitution. Well, here's another way that you can find that point of intersection, and I think you're going to find this a lot easier than what you were doing before. Okay, so let's say I was given this problem, x plus 3y equals 9 and x plus 2y equals 7, and I was asked to find my point of intersection or my solution. The way you do it with combinations, or you can call it elimination, is you make this a problem by putting a line under it, and you're going to look straight down like this. And your goal is to get rid of one of your variables so you can solve for the other. So that means, let's look at this bottom one and go, okay, what could I cancel out with up here, this x? How could I make the x cancel out with it? So what I do is I pick a number to multiply the whole equation by so that it will cancel out with one of these up here. So I'm going to pick -1 because -1 would give me a negative x, and a positive and a negative x cancel out. So let's rewrite our equations here. X plus 3y equals 9. Then I'm going to multiply my -1 by everything. So I have a negative x, a minus 2y, and a minus 7. So all I did was take one of the equations and multiply it to change it. So now what happens is my x cancels out, and I look straight down just like an addition problem or a subtraction problem. I have 3 minus 2, which is 1. And I can put 1y if I want, but I don't have to. 9 minus 7 is 2. So I found my y value. Now I just take that y value and I plug it back into one of my original equations. So I'm going to have x plus 3 times 2 equals 9. Now I'm going to solve for x. So I have x plus 6 equals 9. Subtract my 6. X equals 3. My point of intersection is going to be 3, 2. Let's look at a different one. This one's a little more complicated. So I put a line under my problem. I look here. I have a 2 and a 7. I don't really want to multiply both the equations to change it. So I'm going to look here. I have a 1 and a 5. I could multiply this y times 5 to make it cancel out with a -5. So I'm going to do that. And take this and I'm going to put 5 here. So I'm going to rewrite my top equation. 2x minus 5y equals 7. And then I'm going to multiply the bottom. So I have 35x plus 5y equals -40. Now I'm just going to look vertically down. These cancel out. And I'm going to have 35 minus 2 is 33x. And 40 minus 7 is 33, and it's a negative because of that. I'm going to divide out my 33. So I'm going to get x equals -1. Now I'll take my -1 and go back to one of my original equations and plug it in for x. So I go -2 times -1 minus 5y equals 7. So -2 times -1 is 2. Minus 5y equals 7. Solve for y. So -2, -2. Negative 5y equals 5. Divide by -5, and I get y equals -1. So my point of intersection for those two equations would be -1, -1. So that's a start with combinations and elimination. You can call it either one with systems. We'll talk about it a little bit more on Monday night as well, but be ready with these notes when you come in on Monday.